Hello guys, welcome to the second tutorial. In the last tutorial, I gave a brief introduction on sets and we discussed about various types of sets and their representation. In this tutorial, we are going to learn one of the most important topic of this chapter, which is subsets. So to begin with, let's take two simple sets A and B, such as A has 5 elements and B has 3 elements. Now, if you look at these two sets carefully, you will see that all the elements of B, which are 2, 3, and 4, are already present in A. So, the smaller set B is called a subset of A, and we represent this in mathematical form using this special symbol in between the name of the two sets. This special symbol stands for is a subset of. So B is a subset of A. So in general, if someone has to give the definition of a subset, then what will it be? That if A is a subset of B, then all the elements which are present in A should also belong to B, and we represent it in mathematical form like this. The special symbol between the set A and this element A stands for belongs to. Now we have the same two sets A and B. Now I'm going to tell you more about the different types of subsets which we have. So if A is a subset of B or B is a subset of A and A and B are not equal, then B is called a proper subset of A, like in this example itself. We can see that B is a subset of A and B are not equal. Therefore, AB is a proper subset. And the bigger set A, from which the subset is derived, it is known as a superset. So A is a superset in this case. Now let's talk about power sets, what they are. Power set is nothing but just a set which contains all the subset of a particular set. For example, if we take a simple set A which only has 2 elements and write down all the subsets it can have in a set, then how will that set look like? It will look like this. So in this set we can see we have 4 elements and all those elements are a subset of A. 1 belongs to A, therefore it is present there in its power set. 2 also is present in A. The whole set 1, 2 is also present in A, and the special symbol is called phi, which denotes nothing but an empty set. An empty set is just a set which does not contain any element. We can represent it by using the two curly braces also, or using this Greek symbol phi also, and both of them denotes the empty set. Now how will it determine that how many subsets a particular set will have? Looking quite difficult, but it's not that difficult. There's just a simple formula for it. If a set A has A elements, then the number of subsets it will have will be 2 power A. A very simple formula, yet most of the questions come from this small formula only. So I think it is essential for you to remember it. Now coming to Venn diagrams, they are nothing but just diagrammatic representation of sets named after the English logician John Venn, who discovered it. Now before we proceed to learn more about Venn diagrams, let us first understand what are universal sets. Universal set is the basic set relevant to a particular context. For example, if we talk about the number of students in class 11th, then the universal set for this set will be the number of students in that school. Or I should rather give a more mathematical example. Say if Z is the set of integers, then the universal set for this set may be the set of all real numbers. So I've just mentioned that example, and this universal set is represented by a big capital U. So as you can see in the diagram I've just given here, U is a universal set which contains 6 elements, and A is a set of all even numbers from universal set. So the bigger outer circle denotes the universal set, and the smaller circle denotes the A set, and it is smaller and present within U because as it can be seen from the diagram also, and from the looking at the sets also, that A is a subset of U. So that's why it's presented that way. That's it for now. Hope you guys to see in the next tutorial.